Hello, everyone, and welcome to the Adafruit Show and Tell. I'm Liz. I'm going to be your host this evening. If you would like to join the stream, show off what you've been working on, you can find a link in the live broadcast chat over in our Discord at adafruit.com, adafruit.it/Discord. Links right there. Click on. But first, we're going to kick things off with Adafruit folks, see what they've been working on, and we're first going to hear from Tim. Hey, Tim, how are you?
Hey, Liz, I am doing very well. Thank you. I hope you're doing well as well. So I have brought by what I have been working on this week and towards the end of last week, which is the Teenage Engineering TINGFX or EP2350, which is a little microphone device that they sell. They sell lots of other audio widgets, which I don't have as much experience with. My understanding is this one's like an add-on that's supposed to plug into a sequencer or a sampler or something like that. But it has got a cord here, which I won't unplug, but it's got a 3.5mm jack that comes out the cord there. And then it's got a microphone, and it's kind of like a little CB radio style thing where you've got the paddle on the side. There's a couple buttons on this side, and there are some LEDs in here. And I have been working on getting CircuitPython on this. This device, when you first buy it, it comes with a firmware that's built on MicroPython. So I should say also, hug report to Teenage Engineering. I think this device is really cool the way that it is physically designed. It's relatively easy to take apart, which is really cool. Thank you to them for that. And it is also built on MicroPython, which is also, of course, very cool to see stuff coming out that is built on top of that. Totally. The stock firmware that is on it, though, it handles lots of stuff in its own core. So it's kind of embedded in the firmware. They've customized it to initialize all the hardware and to do all the fun audio stuff. So you can do all of the customizations that they give you with the config.json file. But you can't necessarily dive into the code and just do whatever you want with it. So I've been trying to get CircuitPython on it so that we can have more of that latter experience where you can just dive into the code and do whatever you want on it. And I've gotten pretty far. I have board def up and running, and it's got all the pins mapped. The pin mapping took me a little bit, but I did get lots of help from Claude on this. I was able to plug it in and give it output from the audio so that it could hear what this thing was outputting, and it was able to go through and read the Raspberry Pi registers and do all kinds of stuff to figure out which pins were connected to which peripherals. So I will launch it over to this, which runs this little demo program that I put together just to show that we have access to all the peripherals. So there's some LEDs that we can light up with this button. These buttons also are hooked up to print, but they don't do anything else. And then the other thing I have right now is the paddle will apply a voice effect to it. I can't show off. I do have the audio working, but I can't show it off here on Show and Tell because I cannot get my my microphone to actually feed in from this one into the browser. So I've been recording from Audacity, and it shows up there just fine. What I'll do is, as long as Discord will let me, I'll drop a WAV file that has a recording of me testing it out and applying some pitch shift effect to it. So really cool stuff that you can do with it. There are still some bugs being worked out, but it is coming along nicely. And again, huge thanks to Teenage Engineering for the really cool hardware, easy to take apart, MicroPython inside. What's not to love? So
very cool. And I'm curious, have you done something like this before where you do the tear down and figure out how the hardware is connected and then try to get CircuitPython running?
No, this is my first time for that. Yeah, so figuring out the pins was a bit of an adventure. I kind of went and probed with the multimeter for a while. There are loads and loads of touch like test points, so I probably could have figured it out from those. But I decided to just to throw Claude at it and seeing if it would figure it out by going just software. I did give it the binary as well, so it did some static analysis of the binary. But most of everything it figured out live on the device, which is really nice because it was running CircuitPython. Cool. It could connect to the REPL and just run stuff live. We figured out a lot of it on the actual, firmware that's meant to run on it. And then I did also stick stock MicroPython on it to free up all of the audio peripherals and stuff to make sure that we could check on those without interrupting things, because that crashed it a few times. Gotcha. So yeah, first time doing that. And then really this is my first time doing a board def for CircuitPython as well, I believe. So I've done edits, but never kind of the full spin up.
Well, that's awesome. So learning a lot, and I'm looking forward to the guide on this. Really cool.
Definitely. Yep. Thanks, Liz.
Cool. All right. Have a good one.
Yep. You too. See ya.
See ya. All right. Now we're going to hear from Scott.
Hello.
Hey, Scott. Hey.
You can hear me. I'm a Game Boy today.
Yes.
Nice. So what's in this Game Boy? Well, it's a Game Boy Pocket, and it's got my Game Boy cart in here. And the idea with
cool.
the Game Boy cart is that it's got CircuitPython running on this RP2040. And what it's doing is it's basically telling the Game Boy what to do rather than the Game Boy deciding what it wants to do. So if I turn it on, we can see that it says Adafruit.
Yeah. And I heard the little plink
Yeah, it
there.
does the ding. That's not coming from the cartridge, though. That's actually...
Oh, that's not.
And yeah, for some reason it does it twice.
Okay.
But it should go... So, yeah, I guess it does once when the board starts up, and then it does once when code.py runs, because my code.py, I think, is calling reset.
Okay.
So what this is showing is... This is a demo I just, like, literally had a clanker write. Turns out they're pretty good at Game Boy assembly, which is great.
Cool.
So you can see there that there's a little sprite that moves as I press the button.
Okay.
And it has loaded like other sprites for the background. So this is proving that we're able to like tell the Game Boy what to do and load into like its memory, like what it should show on the display. And it's doing all of the reads of the gamepad too, which is not easy as well.
Right. Yeah.
So we're getting there. I did have it did a separate demo that audio is working. It like played like a C major chord for me as well. So I'm trying to get some of those older demos I have from years ago when I did this originally going.
Right. Yeah.
The Celeste one is like not fully working, and I'm not entirely sure why.
Gotcha. Well,
so I'll look at that tomorrow.
Yeah. This is super cool because I knew there's a lot of variables because you've got the brand new hardware and then you got to write all the code for it. I'm curious, just 'cause I'm not too familiar, when it's connecting to the Game Boy, is it stuff that's happening in CircuitPython core or is some stuff in like code.py?
It's mostly in code.py. So so the core's job is to basically send commands to the Game Boy. So it's the Python level that's saying like, oh, I want to like change this register or load this asset or play this sound. And so the core is doing really basic, like I'm keeping track of when like a frame happens, because you can only change sprites like in between frames. And so the core code is managing that for you. But the interface that the core provides up to code.py is like really low level. It's like, give me some Game Boy like code instructions to run and I will run them. And so I like accidentally like had the LLM generate some test audio code, and at the end it was like, oh, and now we're going to enter an infinite loop, and it's like the infinite loop like actually stopped it from working.
Gotcha.
But luckily we're actually like the Game Boy cart has reset line access. So that's why you saw it start up twice, is that from CircuitPython you can actually reset the Game Boy. So if you ever do have an error that hangs the Game Boy, you can actually reset it from the cart itself.
That's really cool.
So when doing code.py, if you do a mistake and you send an infinite loop, like you just say reset, and it will reset the Game Boy for you and rerun. That's why this code.py example does that. It's just like, let's get it in a fresh state every time we run.
Well, I'm looking forward to hopefully playing with one soon. And are you deep diving this week?
That is the plan, but as always, I have 2 young children. So
of course. All right, well, awesome to see progress on this.
Yeah, it's been a while.
Yeah, it's cool.
Thanks for asking, Liz.
No problem. Have a good one, Scott.
Bye.
All right, now we're going to hear from Erin.
Hello.
Hey, how are you?
Good. I'm doing great, actually.
Good.
My new project this week is this dress that I am working on. It has polka dots, which is exciting. And I have put LEDs inside the polka dots and lined them all up right in there so that you can see them kind of twinkling.
Very cool.
Part about this dress is I'm using the Propmaker RP2040, which has an accelerometer. So I wrote some, me and ChatGPT wrote some CircuitPython code so that dance reactive, and it does a whole little flare up when I jump. So it's really good. Like I've tried some reactive stuff before, and it always like triggers when you don't want it to, but somehow like I don't know, it's working really well. So I'm quite excited to take this dancing.
Very cool.
Yeah, it's really good. So this is my project I've been working on this week, and should be a tutorial hopefully in the next couple days. I'm just finishing up all the video and everything this week. So
nice. Yeah, you did a great job lining up the polka dots. I love how the dress diffuses it. It's really cool.
Yeah, so it was pretty, I had to try 2 or 3 different methods. I tried sewing them on, and that just made it look terrible because the fabric on this is really thin, and you could see all the wires. And I was just like, that's not going to work. In the past, when I've made wearables, I've used like I'll put a slip underneath and put the lights on that, so then I can just watch the dress or whatever. But in this case, that didn't work because the slip just didn't stay lined up with the polka dots. And
because that's be so exact.
Blurry. Yeah. So I ended up having to actually put the pixels on the dress itself, and I used actually little glue dots, and the glue dots hold the pixels in place. And then they make them diffuse as well. So I don't know how well you can see, but instead of just one little point of light, because of the glue dot, I get the whole polka dot lighting.
Spreads it out. Perfect.
Yeah, which is really cool. And then I put iron-on interfacing on the back so that it's not gluey and sticky. And it made it really easy to get the pixels in place too, because I just was able to just press them down and they stayed. It was very cool.
Nice.
So like it was a little tricky, but I went through all of that in the build tutorial. So it's gonna be up soon.
Excellent. Looking forward to it, Erin, and hope you have a good one.
Thanks so much.
Okay. Bye. All right, now we're gonna hear from folks in the community, starting with George.
Hello.
Hey, George. Hey.
How are you doing?
Good. How are you?
Good. So another handy tip this week. I was digging through some of my old stuff because I was looking for a connector I could use. And I had almost forgotten about this box that I'd ordered a while ago from...
George, I just want to stop you for 1 second. I'm just seeing that it's just the OBS preview for your video. Is that what you want to be showing, or do you need to switch your...
I don't know why it's doing that. I might have to come back then, because this is very much a show and tell tonight.
Gotcha. Okay.
So
if you want to... if you want to just pop out and then come back in, then I can get right back to you.
Great.
Okay, very good. So while George is doing that, I can show you quickly what Noe and I are working on. We're working on a voice box recorder using a lot of the new I2S in stuff that Tim's been working on in Circuit Python. So it's got the I2S mic in the center and then a speaker. And so the idea is that you'll be able to record like a quick voice clip, and then it'll loop, and then you'll be able to play with it with different effects and stuff. So that's going to be coming from Noe and I shortly. And now I see that George has come back, so we can see what he's been working on. Hey, how are you?
Great. We'll do it live.
Yeah. Perfect.
So handy hint, I was digging through some old cables of mine, and I had almost forgotten that I had ordered this a long time ago. I've actually used it quite a little bit, but it's a great reference, and it's from Dangerous Prototypes. I'm sure you're familiar with them. They're the people who made the Bus Pirate, if you don't know who they are. They don't update their blog anymore, but their blog, if you're into electrical engineering and you want to go into the weeds, take a look at their blog and go back a bunch of years through their posts, and they have some app notes of some really good stuff. There's Ian, the gentleman that runs it, I believe, moved to Shenzhen, I think he may still live there, but he's really plugged into the community there, and cool. His blog is worth a browse if you want some cool stuff. He hasn't updated it in a while, I noticed, but to get to my point, so this is a sample pack of connectors that you can order. I believe you can still order. He started, after he made the Bus Pirate, he started a company called Dirty PCBs, and it was one of those PCB houses where you take in orders, and then you take everyone's order and you put them on a board and have that board manufactured, and then do the shipping off. So you're not actually manufacturing the PCBs, but you're distributing them. So he started a company doing that. And then on the heels of that, Dirty PCBs, he started Dirty Cables. And so this is from Dirty Cables. And so let me just switch cameras here. What you get is you get this box, and you get quite a few cables. I don't know if you can see that, but so you get little cables, big cables. And the reason why I'm bringing this up is because a lot of times when you're ordering something, you just don't have an idea of exactly how big things are.
True.
And so this gives you a real, for not much money, gives you a real hands-on demonstration. So here's just well, this is a little deceiving. Here's a 2mm IDC. But when you take a look at it, that you can still solder that. That's not too bad. But then when you get down to, let's see here, what are these? I think this is like a 1.25 IDC.
Oh yeah.
Online, that probably doesn't look too hard for you to do. But when you get down to it, when it comes to solder it becomes a little bit of a challenge. So these cable packs are real interesting. And include some samples of wires. Here's some RCY connectors, which are real popular in the RC model world. And then he has some real chunky boys. This is a VH series and a CH series. These are real popular in things like car alarms for some odd reason, and different board-to-board type of stuff. But it just gives you a nice package, rather than you trying to go out and trying to find all these different connectors yourself of what's the most popular. And of course, they also have the SH JST SH series, which is Stemma QT connector.
Very cool.
So yeah, if you're just getting into electronics and you're looking for a good way to get a sample pack of connectors, so you know what they look like, you know how robust they are. You can check the data sheets for how much current they carry, but sometimes having something in your hand is a lot better, and you get a sense of an idea. Is this going to fit into the case that I'm going to do?
Yeah.
Can I hide it in a dress? Can I do this? Can I do that?
Yeah, and even feeling like how robust the actual wires are too. Yeah.
Right. Is it yankable or not? Yeah. That's a big one too.
Yeah. Well, very cool. Thanks for coming by and sharing that tip.
Sure.
Cool. All right. Thanks, George. All right. That is going to do it for show and tell. Thank you, everybody who came by. Some great tips, some great projects in progress. So tomorrow we're going to have JP's workshop at 4 p.m. Eastern, and then Friday Scott will be deep diving, and that will bring us through to the end of the week. So until then, hope everyone's staying cool in the summer, and hope everyone has a good night. Bye.